Today we're going to talk about operations with decimals. You may be familiar with this, but we're going to go back over and review it so that we make sure that we're teaching it right to our students. Let's first talk about adding and subtracting decimals. We know that when we add or subtract decimals, we have to line up the decimal points. You're going to line the numbers vertically so that the decimal points line up under each other and that the corresponding decimal positions are in the same column. In other words, you have the tenths of one number under tenths of another number, hundredths under hundredths, and etc. And all you do is add or subtract the numbers as if they were whole numbers, leaving your decimal place where it's at. Let's look at an example. To add or subtract decimals, you place a decimal point in the resulting sum or difference directly under the other decimal points. So in example 1, we're going to add 9.813 and 2.140. So when you do that, you're going to line them up as you can see in our example here. Line them up, and we're just going to add them. 3 plus 0 is 3. 4 plus 1 is 5. 8 plus 1 is 9. Wherever my decimal point was, it stays in the problem in the same place. 9 plus 2 is 11. If I wanted to add three numbers, 841.0056, 47.016, and 19.058, you're going to see that I lined them up. I'm just going to place the decimal point right where it is up under the others. We're going to line our decimal points up, and we're going to add, making sure all our place values are the same. So 6 plus 0 plus 0 is 6. 5 plus 6 is 11. Plus 8 is 19. So I take the 9 and carry your 1. 1 plus 1 is 2. Plus 5 is 7. 0 plus 0 plus 0 is 0. Wherever my decimal point is stays. And you continue adding just like you would a whole number. The answer is 907.0796. In example 3, the same thing applies if I were subtracting them. You're going to line up those decimal points and you're just going to subtract. So 4 minus 0 gives me 4. You see that the decimal place is in the same values, and you subtract just like we normally do. I can't take 8 from 1, so I have to borrow. That makes that 11, so 11 minus 8 is 3. We took 1 away from the 3 and it became a 2, but I can't subtract 5 from 2, so I have to borrow from the 1, making that a 0. So 2 plus 10 is 12. Now I can subtract 5. 12 minus 5 gives me 7. So my answer is 0.734. When we multiply decimals, it's different than adding or subtracting. We're still going to multiply the numbers as if they're whole numbers. But we want to find the sum of the number of decimal places that we have in our factors. And after we've multiplied all of our whole numbers together, we place a decimal point in the product or in the answer of that multiplication problem in the correct place based on the sum of the decimal places in those two factors. Okay, so let's look at an example of what we mean by that. If I wanted to multiply, like in example 4, 1.46 multiplied by 3.2. You simply multiply as if there were no decimal places, 292, 438, and then you count your decimal places. In the first factor, I had 2 decimal places. In the third factor, I had 1 decimal place. So that means that I'm going to move my decimal place or my decimal point 3 places. So when I multiplied, I got 4,672 because I had 3 places. We move over 3 places, and that's where I put my decimal point. Let's look at another example. 0.0251 multiplied by 0.00113. We want to find the product, so we're going to multiply those two together. And so you can see how we're doing in our example. We're just multiplying them out, just basically disregarding the decimal point. When I get everything put back, then I go back and look at how many decimal points I had. In the first factor of 0.251, you can see that I had 3 decimal places. I see that I need to correct this right here. So I'll go back and correct that. So we have 3 decimal points. I wrote it wrong in example 5. I had 5 decimal places on the bottom, so that's the total of 8 places. So you can see that I'm going to move my decimal point 8 places to the left. So my resulting answer should be 0.00028363. When you're dealing with decimals, it's very easy to multiply by powers of 10, just like in other things. When you multiply by a power of 10, all you have to do is move the decimal place 1 place to the right for each power of 10. So if you're multiplying by 10 only, you would multiply the decimal or move the decimal 1 place to the right. If you're multiplying by 100, you would move the decimal place 2 places to the right. Basically, however many zeros is in the power of 10, that's how many places you're going to move it. That is if the exponent is positive. You're going to do the same thing, but in the opposite direction. You're going to move it to the left for each power of 10 that's negative. Let's look at some examples. If I'm going to take 0.274 and multiply by 10, I got 1 0. I'm increasing, so I'm going to move it 1 place to the right. So my answer becomes 2.74. No calculator needed. In part B, 0.39 multiplied by 100, I've got 2 zeros. 100 represents 10 to the second, so I'm going to move it 2 places to the right. So 0.39, moving my decimal 2 places to the right, I just get the whole number 39. Can you see how many decimal places that I would move it in part C to the right? I have 3 zeros, that's 10 to the third, and if I move it 2 times, I run out of room, so I have to add a 0. So 15.32 multiplied by 1,000 is 15,320. D is the first one in which I have a power of 10 raised to a negative number. Again, though, we see that this is the tenths place and the hundredths place. So we think about 1 over 100. That is the same thing as 10 to the negative 2. I can even express this 1 over 100 as 1 over 10 to the positive 2. When you take anything and you move it from the numerator to the denominator or vice versa, from the denominator to the numerator, the only thing that changes is that exponent becomes negative. So that's the same thing as 10 to the negative 2. Now in this case, since I am multiplying by a negative, I'm going to move my decimal point 2 places to the left. So I get 0.423. Now let's talk about the division of decimals. In long division, for dividing decimals, we never really actually divide by decimal. Before we even begin dividing, we make an adjustment so that the divisor is always a whole number. Look at what I'm talking about here. To divide a decimal, the rule for dividing by a decimal is to count the number of decimal places in the divisor and then move the decimal points in the divisor and the dividend that many places to the right. Okay, so let's look at this example. We're going to take 32.66 and we're going to divide by 7.1. We're going to find the quotient, the answer to a division problem. You see that 32.66 divided by 7.1. You'll see that on the outside, the 7.1, our divisor has 1 decimal place. So because 7.1 has 1 decimal place, I have to go inside and move that 1 decimal place as well. And wherever that decimal point lands, that's where it's going to land up here. So because I had one decimal place here, I had to move it one decimal place there. And then you just divide as usual. 71 goes into 326 4 times. 4 times 71 is 284. When I subtract, I get 42. I bring down the 6. 71 goes into 426 6 times. 6 times 71 is 426. I don't even put my decimals in here, because once I put my decimal in, that's where it's going to be in the answer. Let's try another example. 1.0773 divided by 0.13. This is our divisor. It has 3 decimal places. So if I have 3 decimal places here, I'm going to have to move my decimal place 3 places on the inside. And wherever that's laying, that's where my decimal goes. And then you divide long division just like you would. 513 goes into 1,077 2 times. 2 times 513 is 1,026. When I subtract that, I get 51. I bring down the remainder of 3. 513 goes into 513 one time. So my answer is 2.1. Basically, after you move the decimal points to the correct position, it's nothing more than dividing whole numbers. We can also easily divide by powers of 10. There are 2 ways that we need to think about when we're dividing by powers of 10, whether the exponent is positive or the exponent is negative. To divide a decimal by a power of 10, move the decimal point one place to the left for each power of 10 if the exponent is positive. And we're going to move the decimal point one place to the right for each power of 10 if the exponent is negative. Notice it's the reverse of multiplying by powers of 10. So in this simple example, 9,248 and 6/10 is divided by 100. 100 is 10 to the second. And so that is positive 2. So we've got 2 zeros in the power of 10. We're going to move it 2 places to the left. So if I move it 2 places to the left, I get 92.486. Positive exponents, we move to the left. All right, let's do another example. 3.28 divided by 10,000. All right, we have 4 zeros here. 10,000 is the same thing as 10 to the 4th. Again, we have a positive exponent, so we're going to move to the left 4 spaces. When we go to move to the left, I don't have any more units, I only have 1, so that's when I have to add those 3 zeros. So 0.000328 would be my answer. Now we're dividing by powers of 10 in which our exponent is negative. Remember when we were talking about place value, this was 10 to the negative 1. This was 10 to the negative 2. This was 10 to the negative 3. So 0.001 is 10 to the negative 3. If it's negative exponents, we move to the right. So 1, 2, I need to add a 0. So 4.52 divided by 0.001 is going to be 4,520. Take a little time to make sure that you get these rules down correctly and you move in the right direction. As we mentioned in lesson 23, that a fraction can either be turned into a repeating decimal or a terminating decimal. A repeating decimal can be written as a fraction whose numerators and denominators are integers. It's a little bit harder to write the repeating decimals than it is the terminating decimals. So even though we know that when we divide a fraction out, it's going to either terminate, which means our decimal stops, or that our decimal repeats. But either way, it doesn't matter if it terminates or repeats. We can take a terminating decimal and we can convert it back into a fraction, but we also can take a repeating decimal and convert it back into a fraction. So I'm going to show you, first of all, how we take 0.47 and we're going to write that as a fraction. So this is 47. It's in the hundredths place value, so that's 47 over hundredths, tenths, hundredths. We're going to check to see if that can be reduced. I cannot reduce 47 over 100, so I'm done. But here's a tip for converting repeating decimals back to fractions. If I have 0.8888, that is 0.8. Notice that is the tenths place. So our denominator is going to be 1 less than that, so we're going to do 9, and then whatever number you have, it goes in our numerator. So 0.8 can be turned back into a fraction. That's 0.8 repeating into 8/9. Another tip, 0.5 repeating, that's still in the tenths place. So our denominator is 1 less, that's 9. Whatever the number is, that's the number for our numerator. 0.05 in the hundredths place, we go 1 less, so that's 99 for my denominator. And I have 5 on top. 0.376 repeating, that is the thousandths place, so I go 1 less, that's 999, and whatever number repeats goes in my numerator. So this is just a tip for converting some simple repeating decimals back into fractions. All right, so let's try it. Example 13, 0.17. All right, so this is tenths, hundredths. I go 1 less, so that's 99. Whatever number is there goes in my numerator. 17 over 99. 0.7 is the tenths place, so we're going to go 1 less. That means the denominator is a 9, and the 7 is going to be carried to my numerator. 0.238. 238 thousandths. So we go 1 less than 1,000, that's 999, and 238 goes on top. And part D would be 18 over 99, but be careful. We know that we can reduce both of those by 9. So 18 divided by 9 is 2. Remember the trick for double digits, 99 divided by 9 is 11. Always make sure every fraction that you do, that you always reduce it to lowest terms. In example 13, we're going to replace each repeating decimal with a rational number, so the same thing. Tenths, hundredths, so 32 over 99. Again, a repeat. Tenths place, so that's 8 over 9. Tenths, hundredths, thousandths in part G, so 999 is our denominator, and 631 on top. Converting these repeating decimals to a rational number or a fraction. We also can make decimal equivalents. Sometimes in computing products mentally, it helps to recognize decimal equivalents of a few simple fractions. And these are things that you should be considered, and we call them compatible numbers. But as you start seeing decimals and fractions, you should start making a relationship that they are compatible, they are equivalent. Some of those that you're going to see a lot of times is 0.25. You should know without having to type that in a calculator. That is 1/4. 0.2 is 2/10, which reduces to 1/5. 0.8, that is 80%. 8/10 reduces to 4/5. Number D, 0.5, 5/10 reduces to 1/2. You should know that 0.5 and 1/2 are compatible numbers. When you see that, that shouldn't be something you have to divide out. That 4/10 is 2/5, 0.4 and 2/5. 0.125, you should make the connection that it's 1/8. That's just something that you see. You should be able to convert them easily back and two with each other. Common knowledge, sort of like memorizing your multiplication tables. These are things that you should start to remember and would not have to plug them into a calculator. 0.75 is 3/4. And 0.6 is 6/10, and that reduces to 3/5. So try to get accustomed to what these common decimal equivalents are and their fractions, these compatible numbers, so that as you're doing word problems or as you're doing lessons, you're going to be able to use the compatible numbers without actually having to plug it into a calculator or to figure out what that fraction is. Should be common knowledge.